What is root 2 raised to the power of root 2 raised to the power of root 2 raised to the power of root 2 over and over again? Turns out it's equal to 2. Now, to show why that's true, we need to invoke something called the Lambert W function, which I actually don't want to go into today. Rather, I want to actually explore this equation, x to the x to the x to the x power and so on, equaling potentially some constant k. This is known as an infinite exponential tower or infinite tetration in math, or a power tower, which sounds so much cooler than the other two names. And let's ask, what is the largest possible value for x such that this infinite exponential tower can still converge to some real number k? So to figure that out, let's employ a very useful mathematical trick here, which is plugging the equation back into itself. We can now express this equation as x to the power of k equaling k. I'll let y'all think about that for a moment, why that's true. In any case, now we can raise both sides to the power of 1 over k, so we have now x equaling k to the 1 over k power. Now, to maximize this function, we need to take its derivative. So using logarithmic differentiation, which I talked about in a previous video of mine, we will get the following. I'll just put the steps here and you can pause to study it more. But essentially, what we get is that the maximum value for x will occur when k equals e. Now, how do we know that this is going to be a global or an absolute maximum for our function? Well, we could take the second derivative and apply the second derivative test here, but we could also just recognize that the domain of our function is going to be 0 to infinity, non-inclusive. And since k equals e is the only critical point on that domain, and we see that this is a relative max for a function, then it has to be also a global or absolute max for our function as well. In any case, I'll let y'all verify that if you want with the second derivative test. But this means that if k equals e is a maximum, then the maximum value for x would be e to the power of 1 over e, which is going to be about 1.44, I believe. And so that is the largest possible value for x that you can plug into our infinite exponential tower so that it still converges to some real number k. In fact, that real number k is e. So this is yet another way to express e. Now, we can also ask what is the smallest x value that can be plugged into this infinite tetration so that it still converges to some real number. But I'll leave that for another video. That's going to be a little bit more involved. But in any case, I hope you're doing well. Make sure to hit that follow button for more math content. I would greatly appreciate it. And as always, I'll catch you on the next one. Take care.